So today we're going to start looking at lesson 3.6, solving inequalities, which is a lot like solving equations. Okay, so in here you see that, and we talked about this, in an equation you can change each side by the same amount to write an equivalent equation. And we talked about that. Whatever you do to the left side, you must do the same thing to the right side. So if I move these up a little bit, zoom them, there you go. So on the left side of this equation, you have 8 plus 4 is 12, or is the same as 12, right? What if you, on the left side, 8 plus 4, but then you subtract 3? Well, as long as you subtract 3 to the right side, they're still going to be equivalent because you're doing the exact same thing to the left and the right side, the left expression and the right expression, okay? In an algebraic equation where you have a variable, 8 plus some number c is the same as 12. Well, 8 plus c subtract 3 is the same as 12 subtract 3. So they're doing the same thing. All they're saying is, okay, so originally it was 8 plus c, and that was the same as 12. Well, now you have the 8 plus c, but you're going to subtract 3 on the left side, the left expression. Well, as long as you do the exact same thing to the right expression on the right side of the equal sign, they will still be equal, okay? So inequalities, same deal. And I can prove it here. 8 plus 4 is less than 15. Great. Well, 8 plus 4 subtract 3 is less than 15 subtract 3. All they're doing is taking this original inequality and subtracting 3 from both sides of the inequality. As long as they were equal, as long as you had a true inequality over here to start with, and it is because 8 plus 4 is 12 and 12 is less than 15, then when you do whatever to the left side of the inequality, as well as to the right side, as long as you're doing the exact same thing, and they're subtracting 3 from both sides, they are still going to work, right? 8 plus 4 is 12, minus 3 is 9. 15 minus 3 is 12. Well, 9 is less than 12, so it still works. And down here, it's the same thing. They're just showing you an inequality in algebraic form with a variable. And all they're doing is saying, originally I had 8 plus c, whatever that is, greater than 15. Well, all they're doing is saying, here's the same elements, 8 plus c, 15, but I'm adding 3 here and I'm adding 3 here, so it still works because you're doing the same thing to both sides. Okay, solving. Now, which numbers are solutions of the inequality 3k is less than 21? In other words, which one of these numbers, 4, 7, or 12, when you substitute it for k, because remember 3k is the same as 3 times k, will work, make this inequality true, right? So you have to test each number, okay? So what they did was, first they replaced it, 3k less than 21, we're doing the 4, replace the k with the number, 3 times 4 is 12, and 12 is less than 21, so this works. 3k is less than 21. Well, replace the k with the second number, 7. 3 times 7 is 21. 21 is not less than 21, so that doesn't work. And the last one, 3k is less than 21. Replace the k with the number 12 to check it. 3 times 12 is 36, and 36 is not less than 21. So only 4 is a solution. You're going to have quite a few of these when you work with inequalities for a graph. And you're going to have to go through and see which ones work. Okay, so sometimes this will take a little bit because you're going to have to practice with it and you're going to have to find the solutions. Okay, decide whether each statement is true or false. So here's a graph. Now first, what I would suggest is think, what does this graph show? Okay, well, there's a couple things. One, it's pointing to the right, so therefore it has to be something about greater than, right? where does it start? Well, it starts at 5. So we're going to say that that graph shows x, whatever number x is, greater than 5. Now I'm going to check to see what about greater than or equal to. Well, it's just greater than because the circle over here is open, right? It's not filled in, it's not closed. So if it's open, then you read it, where'd you start? So it's greater than because it's pointing to the right, but 5 is not part of the solution because the circle is open, not closed. If it were closed, it would be solid blue. So this graph says x represents all numbers that are greater than 5. Now you have to figure out which ones of these work. Well, this is what you got to do. Okay, so you have to look at the first one, which is 3x is greater than or equal to 15. You have to solve it. So just like with equations, you would write 3x is greater than or equal to 15. And then you're going to have to go below it. So first write the inequality symbol. Okay. Oops, hang on. Let me do this first. I have to get the x, that's right, all by itself, so that it looks like this. X is greater than or equal to some number. Well, to get rid of that 3, think, what are you doing with the 3? Well, you're multiplying it, aren't you? You're multiplying it by x. Well, what's the inverse of multiplying by 3? And remember, inverse means opposite. Well, the inverse, or the opposite of dividing by 3, this is how you're going to get rid of the 3. Or sorry, the inverse of multiplying by 3 is dividing by 3 both sides. Left side, 3 divided by 3 really equals 1. So all you have left is x on the left side. You could write 1x, but 1x is the same as x. On the right side, 15 divided by 3 is 5. Well, this graph does not show x is greater than or equal to 5. It just shows x is greater than 5. So this one is false. We'll just write the whole word because it's not that tough. Then you have to do the next two. Same thing. You have to solve them. And they have to equal, they have to come out, x is greater than 5. Okay, let's do B. 8 is less than x plus 3. Okay, 8 less than x plus 3. Got to get the x all by itself. So to do that, you have to get rid of this plus 3. Well, what's the inverse or the opposite of adding 3? That's right, subtract 3 from both sides. On the right side, plus 3 minus 3, they cancel each other out. All you have left is x. On the left side, 8 minus 3 is 5. Okay, now look at this. This graph shows x is greater than 5. So x is any number that's greater than 5. This says 5 is less than any number x. Now you think about that. These two inequalities are exactly the same. X is any number that's greater than 5, 6, 7, 8, 9, 10, etc. And then all you're doing here is switching it around. 5 is less than x. That means that x is any number that's bigger than 5. And here is something to remember. You can do this, x, and then you have this way, right? 5 is less than x. You can switch these. So now you have x on the left side, 5 on the right side, but you have to remember to turn the symbol around. Yep, you have to turn that symbol, right? Because it was 5 is less than x. Well, if you're going to switch their positions, x is greater than 5. All you're doing is literally turning it around, okay? But you got to remember to turn the symbol as well, otherwise it won't work. Okay, last one. Let's look at this. The graph shows the solution of both x minus 3 is greater than 2 and x plus 10 is greater than 15. Well, let's do one at a time. X minus 3 greater than 2. Okay, left side, I want to get the x all by itself. Oops, I need to get rid of that 2. What's the opposite of subtracting 3? I have to get rid of the 3, the minus 3, adding 3 to both sides. Left side, they cancel out. All I have left is x. The right side, 2 plus 3 is 5. So that works. Let's see if the other side works. X plus 10 is greater than 15. Okay, now I want it just to be x. How do I get rid of plus 10? That's right, subtract the 10 from both sides. Left side, plus 10 minus 10, they cancel each other out, they equal 0. And 15 minus 10 is 5. So this one works. C works. And I believe, didn't we decide? Yes, and B works. So this is true and this is true. Okay, this is very similar to the last example. It's almost identical except the numbers are different. If you need to look at some more examples, keep watching the video. If you feel confident to go ahead and start your assignment, do so. I'm going to go ahead and work through these because decide which statements are true. Well, first I have to decide what this graph shows. Well, it's going to the left, so that means it's a less than. It starts at 8, so that means that it's less than 8. So x is less than 8. X is any number that's less than 8, but look at the circle. The circle is filled in, so that means that 8 is part of 8 is a solution. It's part of the solution. So x is any number that's less than or equal to, because the circle is filled in, less than or equal to 8. So I need to see which ones of these also have that as a solution. First one, 2x is less than or equal to 8. 2x less than equal to 8. What's the opposite of multiplying by 2? Dividing by 2. Both sides. On the left side, they cancel each other out. All I have left is x. On the right side, 8 divided by 2 is 4. Well, that graph does not show x is less than or equal to 4. It was, remember, this graph shows x is less than or equal to 8. So that doesn't work. So this one, no. Let's look at number 2. Get rid of all this junk. Good. Second one, 24 is greater than or equal to 3x. Okay, I have to get the x by itself. So I want to do this so that there's nothing but x on the right side. How do I do that? How do I get rid of the multiplying by 3? Because 3x means 3 times x. What's the opposite or inverse of multiplying by 3? Dividing by 3, both sides. Right side, they cancel out. 3 divided by 3 is 1. Left side, 24 divided by 3 is 8. Now remember what this graph says. It says x is any number that is less than or equal to 8. Now look at what we came up with. 8 is greater than or equal to x. They're exactly the same, right? Because if I switch this around, if I switch the order and the sign, I get x on the left is less than or equal to 8. All I did was completely turn it around. And that's exactly what this graph shows. So this works. Last one. Okay, so I went ahead and did the work with these two inequalities. On the left side, I had x minus 3 is less than or equal to 5. I isolated the x by getting rid of the 3 by adding 3 to both sides. And I came up with x is less than or equal to 8, which matches the graph. Same thing over here. X plus 4 is less than or equal to 12. Well, I had to get the x by itself. To do that, I had to use the inverse operation. What was I originally doing? Adding 4. How do you get rid of adding 4? You subtract 4. The inverse, the opposite. Both sides. Left side, they canceled out. Minus 4 plus 4 is 0. All you have left is x. And then the right side, 12 minus 4 is 8. So we match. So this last option does work. And that's it. If you have any questions, you know what to do. Bye-bye.